Using the meter defined command. The meter defined command requires a background bitmap, the minimum and maximum needle angle values, a needle pivot point, and a set of points outlining a polygon for the meter needle. A program such as GIMP can be used to design the meter needle. GIMP is a free image manipulation program you can download from the internet. In this video, you will learn how to use GIMP to design the needle for the meter defined command. This video assumes that GIMP has been previously installed. You can download GIMP from www.gimp.org. This video also assumes that the SLCD screen layout utilities have been installed. You can download them from www.reachtech.com/tutorials. There's also a tutorial for using the screen layout utilities there. The details of the meter defined command can be found in our software reference manual, available at www.reachtech.com/downloads. We're going to use a meter background bitmap that came with the SLCD screen layout utilities. The file is meter speed, and I'm going to open it with GIMP. You'll notice that the values on the meter range from 10 to 150, so we'll use those values as part of the meter defined command. The next thing you'll notice is that if you were to make a complete circle out of this image, it would go beyond the bottom of the bitmap, and we need that area to define our meter needle, so we're going to grow the image temporarily. To do that, you go to Image, Canvas Size, and then just make it higher. We're going to guess at about 350 pixels. And then you want to resize all layers. This gives you an idea what it's going to look like. And you click Resize. This just gives you more drawing room at the bottom. The reason we need more room on the bottom of the bitmap is because the meter needle coordinate system starts with 0 in the 6 o'clock position, and it increases as it goes clockwise. For the meter defined command, we need to provide the angle of the needle at the minimum meter value and the angle of the needle at the maximum meter value. To do that, we're going to locate our pivot point, measure the length of the meter needle, and then measure the angles. To locate the pivot point, select the pencil tool, change the size to 1 pixel, and then zoom in to 2 to 1 or 4 to 1, whatever looks good on your system, and put just a point at the pivot point by clicking the mouse once. So that's the pivot point for the needle. Next, you can select the measure tool and click on the pivot point and hold the button, and we're measuring the length of the meter needle. So we're just going to pick a size for the end of the needle. You can see at the bottom it's showing about 145 pixels for the length of the needle. Now that we have that set, we're going to set a measure anchor point in the 0 position. You move the mouse to that position and release, and that'll set the anchor point. Now you go back to the pivot point, press the Shift key, then click the button, and it'll pull out another measurement. And this one is going to be referenced to the original one. So the first thing we can do is measure the needle angle of the minimum value. You see on the bottom of the screen it's about 58 degrees. And then we're going to measure the maximum. Now you notice as we cross the 180 degree point, the measurement flips. So at the 150 value, the measurement is showing 126 degrees, but that is this angle, and we need this angle. So to calculate this angle, we'll just subtract 126 from 180, and then add that to 180 to get the full value. Now that we have the needle angles figured out, it's time to figure out the points of the outline of the needle. You can start by hitting Escape to get rid of the measurements. Then select the pencil tool. Make sure the size is still 1 pixel. And then pick a foreground color that's different than your image background color. We'll use yellow for the needle. Next, you're going to want to put a grid on the screen so that you can align your needle correctly. So you go to Image, Configure Grid. For this, we're going to pick a color that's different than the background and the needle, so we'll use red. We'll give ourselves a fairly small size. 5 by 5 works nicely. And last, you want to view the grid, so you go to View, Show Grid. And then I like to zoom in to about 4:1 when I'm doing this work. And then adjust the picture so you have room to work. The first thing you want to do is you click on the pivot point and then hold the Shift key down and move your mouse. And this helps you draw a straight line, and you want to keep going down for the length that we measured before, 145 pixels. And then hit click and release. This sets the length of your needle and also the tip of your needle. For the outline of the needle, we're going to start at the base of the needle in a convenient corner of the grid, and you single click to set the point. Move down to your next point, hit Shift, single click, and that sets the second point of the outline. Then we'll come down to the tip of the line, hit Shift, click again. And now we're going back up the other side. We're trying to be symmetrical, so we'll do Shift, click, and then Shift, click at the last point. And if you'd like, you can go to the first point to close the image. Shift and click. So that's the outline of your meter needle. The next thing you need to do is get the coordinates for each of the points we clicked on. To do that, you hover over the point, and on the bottom of the screen you'll see the X and Y coordinates. So that's the first point. We'll come down to the second point there. We'll come down to the third point, which in our case is the tip there. This is the fourth point, and then the fifth point. Now for each of these points, the information needed by the meter define command is relative to the pivot point. So for each of the X values on the points, you're going to subtract the X value of the pivot. And for each of the Y values of the points, you're going to subtract the Y value of the pivot. The results of these calculations are used directly in the meter define command. Now that we have all the information we need to draw the needle, we're going to go ahead and enter that information into a meter define command. We're going to start by closing the current drawing. File, close all, and we'll discard changes so we don't change the bitmap itself. Next, we're going to open up an SLCD screen layout canvas by going to File, Create, Reach Tech, SLCD, Select, and we'll pick a standard 4.3-inch landscape module. For the bitmap folder, we'll browse to the bitmaps folder from the SLCD screen layout utilities. Click OK, and then you click OK to create the canvas. So this is the size of a 4.3-inch module. Next, we're going to define a meter. We'll go to File, Create, Reach Tech, Meter, and pick Meter. This brings up a very large pop-up, and we'll go through it in sections. The meter index value is the number you assign to the meter. We'll use 0. The bitmap button allows you to browse to the desired bitmap. In this case, we are in the bitmaps folder from the SLCD layout utility, and we'll pick meter speed and click open. Now, the min value and the max value are the minimum and maximum values displayed by the meter. So we've captured that information from our graphic before in a Word document. So we're going to just enter that directly here. You'll see minimum value and maximum value I captured. So that's 10 and 150. The initial value is the initial setting of the needle, so we'll set that to the minimum value of 10. Now the minimum angle is the angle of the minimum value that we measured using GIMP, and that's 58 degrees, so we'll enter that. And the max angle is 234 degrees. For needle color, we use red. If you click on the color, you get a color browser, and you can pick any color you want. The needle pivot point, again, was measured before, so that's 159 and 157. Now for all the x and y coordinate pairs shown here, you enter the relative information from the pivot point of the points we measured before. We have some x values showing here. These are all the x values we measured before. And their x relative is the measured value minus the pivot point. Note that this can lead to some negative values or zero values depending on where your measured point is relative to your pivot point. So we're going to just go ahead and enter all the relative values, all the x relatives and y relatives in these coordinate pairs. So the first one is -5 and 13, -5, 23, 0, 145, 5, 23, 5, 13. For all of the rest of the coordinate points, you'll leave the values set to 9, 9, 9, 9, 9 to indicate that it's an unused point. Lastly, you can set the nickname. We're going to call this meter speed. Now off screen is the OK button. I'll click the OK button, and GIMP will add the image to the canvas. It will put a point on the pivot point, even though that will not show on your final screen image. And it uses an outline for the needle using the coordinate points you supplied. Note that on the final SLCD screen image, this will be a filled polygon. Now at this point, you can go to File, Create, Reach Tech, Output Macro. This will generate a macro command to draw the meter as shown on your SLCD screen. So you click Output, and it will put it in a file called slcd setupmacro.txt in your bitmaps folder. Click OK, and the macro is generated. Now that we have the output macro generated, we're going to bring up BMP load and download the macro and bitmap to the screen and show how it looks. In BMP load, we're going to load BMP list, and then we're going to browse to the folder that has all the screen layout utility bitmaps, and we'll pick the bitmaps list file. This will load a list of bitmaps, even though we're only using the meter speed bitmap, because the macros assign bitmap numbers based on the order found in the file and using the number preceding the name. So we just load them all so it gets the correct one. Next we want to add a macro file, and we'll choose the slcd setup macro that was just generated and click Open. And make sure your COM port is set correctly, and make sure your baud rate is set to 115.2, and then you click Store into SLCD. You'll notice the status shows connected, and then it's downloading. After BMP load is done downloading the macro and bitmap to the screen, we're going to bring up a terminal emulator and show how to invoke the macro. If you do an lsmac command, you'll see the macro generated by the screen layout utilities, and lsbmp shows you all the bitmaps. At this point, we can do a Z, which erases the screen, and then we say macro 1 and hit enter, and you can see that it's drawn the meter and the needle on the screen. If you give it a meter value command, so you say meter value, the meter number, in this case 0, and then let's give it a value of 125, and you can see the needle move. And now we'll give it another value. These are the same commands that your application would use. So that shows how to define a meter using GIMP to work out the coordinates for the needle. You can find source files for these tutorials at www.reachtech.com/tutorials. If you have any questions, give our team a call at 503-675-6464 or send an email to techsupport@reachtech.com.